Hello class, we're going to move on to our next section, 11.2, and this section is called Areas of Circles and Sectors. And sectors are kind of like a certain portion, and we're going to go discuss those definitions momentarily. So the difference between 11.1 and 11.2, 11.1 talks more about circumference, so everything around the circle. Now we're going to talk about the area, which is everything inside the circle. So think of circumference as the perimeter, and think of area as, well, the area, everything that's on the inside. So our first definition is population density, and that is the measure of how many people live within a given area. So technically it is what it says. So population density, we have population, which is pretty much like a group of people, and then density meaning kind of like how many are there in a specific area. And to find population density, this equals the number of people all over the area of land. Okay, so that is how you find population density. Our next definition is sector of a circle. So the sector of a circle is the region bounded by two radii of this circle and their intercepted arc. Okay, so those are two definitions that we're going to be talking about today. More than likely the area of a circle as a whole, and sector of a circle is a good chunk of this section on circles. So our core concept is the area of a circle. And so the area of a circle is pi r squared. So we're taking the radius and we are squaring it. Unlike circumference where we multiply it by 2, this is where you're going to take r squared and multiply r times r in this case. So where radius is the area of a circle. So to find the indicated measure for this first example, we want to find the area with the radius of 2.5 centimeters. We know that area is pi r squared, and we are given the radius of 2.5 centimeters. So the area, we go pi, and r is 2.5 squared. And so if we wanted to multiply 2.5 squared, we end up with 6.25 pi. And if we want to use pi into our calculator, as I said before, we end up with 19.63 centimeters squared. Okay, so that is the first example. And then let's see if we want to try something different. So we have diameter with an area of 1.3 or 113.1 square centimeters. So remember, diameter is double the radius. So let's go and find the radius first, and then we can find diameter. So area, we know, equals pi r squared. We are given the area of 113.1, and you can divide by pi on both sides, so you at least get r squared by itself. And so you're left with about 6. However, let's see if we would plug it into our calculator. So let's see. We have 1 divided by second pi, and we end up with 36.0. So we have 36.0 equal to r squared. And if we want r by itself, we're going to square root. So square root both sides. We know the square root of 36 is going to be roughly 6 to be the measure of our radius. Now remember, the radius is, or if we double our radius, then we get our diameter. So remember, 2 times r gives us d, and d stands for diameter. So now the radius is 6, so that means the diameter is 12. And so that's how you'd use area in order to find diameter. So let's move on to our next. So now we have the area of a sector. So the area of a sector is the ratio of the area of a sector of a circle to the area of the whole circle, and it's equal to the ratio of the measure of this intercepted arc. So we're still using the area, but we're going to take the intercepted arc over 360. And so our printer is a little different, so these are supposed to say measure of the arc, and then we'll always multiply. So remember, pi r squared, that is the area as a whole. Okay, so don't forget that. So our first example is, let's say we want to find the sector area of and we want to find it of UV. So let's say we want to find UV. So UV would be right here. So this entire area, and we know that our central angle is 70 degrees. So let's apply the area of a sector. So we have the area of the sector equal the measure of arc UV, and that's all over 360 degrees, and then multiply by pi r squared. So we know that the arc measure of that is 70 degrees divided by 360, and we know that our radius is 8 inches. And so if we want to type all of that into our calculator, that's multiply. So we have 70 divided by 360, and we get 0.944, and then we can keep that answer and multiply it by second pi, and then you can always use parentheses here, 8 squared, and you end up with 39.10 for rounding to the nearest tenths. Okay, now what if we want to find the measure of the rest of it? So what if we want to find the measure of USV? So we want to find the area of USV this time, so we want the rest of it. No, you cannot subtract, because unlike measures, this is not where it's going to add up to 360. That's different. So we are going to do the same thing. So we're going to take the measure of USV, and USV is the rest, all over 360, and we're going to multiply it by pi r squared. So this time, instead of using 70 degrees, we need to find the rest. So if we want to find the rest of our arc measure, we take 360, subtract it from 70, and we're left with 290 as the rest of our arc measure. So 290 divided by 360, multiply by pi, and then we still keep our radius, which is 8, and square it. And so into our calculator we go. We have 290 divided by 360, and then we're going to multiply by second, hit pi, and then parentheses 8 squared, and we're left with 161.97. Alright, so that's how you use area of a sector to find a particular sector, or to find the rest of it as another sector. So now let's start with some example problems. So we have find the indicated measures. So when we have something like 5 meters or 5 centimeters, note that that is the diameter. So if we want to find the radius, we would take half of it. So 5 divided by 2 gives us 2.5. So that would be our radius this time. So area equals pi r squared, and you take pi and take 2.5 squared, and we're left with 6.25 pi, that's just 2.5 squared, and our final answer in the calculator would be 19.63 centimeters squared. Alright, so let's see if you can do the same with R. Let's see if you can apply the same logic with R. What is our diameter, or what is our radius? Okay, so you're trying number 2 on your own. And let's go on to our next page. So our next example, number 3, we want to find the area of a circle with a diameter of 1.8 inches. So we know we need to find the area, and the diameter is given to us. So remember, we have the diameter, 2 times R equals diameter. So if diameter is 1.8, I need to divide by 2 to get the radius. So that gives me 0.9 as my radius. So area is pi r squared. Pardon the bell. So the area is pi r squared. So I'm left with pi times 0.9 squared. And in our calculator we get 2.54 inches squared. Our next example is finding the diameter. So we have to trying to find the diameter, and we have the area of 10 square feet. So we know we have 10 is equal to pi r squared. So we're going to divide by pi, and we get 3.18 that we need to square root both sides. And so we're left with r equaling 1.78 into our calculator. And note, 2 times r equals the diameter, so 2 times 1.78 gives us 3.57, and that is feet. The only time you'll square is if you're finding the area. Our next example, number 5, we're trying to find the radius. So let's see if you can try to find those two on your own. So we're going to work backwards. So you have the radius, and you're given the area. So I will set it up. So area is 65, and you're trying to find the radius. Number 6, remember you're finding the area, and you're given the radius. Alright, for number 7 and 8, you're using sector area. So you're trying to find the area of both circles. So remember, the arc measure here is 140 degrees. And if I were to subtract 360, the rest of my arc measure is 220 degrees. Okay, so let's see if you can find both of these, use both of these arc measures to find different sectors. And then number 8, you gotta find the area of y. And so you're left with 25 degrees, and you have the area already given of 4.1 square feet. So this one's a little different. So you're already given the area. So you already have 25 degrees all over 360. And you're going to multiply by pi r squared. But we already know pi r squared is the area, so that's 4.1. So let's see if you get a similar answer. And then number 9 is over population density. So remember, to find population density is the number of people all over the area of land. Okay, so you need to find the population density and see if you can find an answer for that one. Thank you so much.